Welcome to the webinar, MathWhiteboard, an online collaborative whiteboard for math. This webinar is hosted by the Network of Assistive Technologists on this Friday, the 25th of June, 2021. We're joined today by Carney from MathWhiteboard. Don has been very active in the fields of computer science and educational technology, both presenting Fluidity Software's research and products, as well as being the principal investigator for many federal research grants and contracts. Don has also been an invited reviewer and panelist for the National Science Foundation, receiving multiple degrees from Rensselaer Polytechnic Institute, Polytechnical University, and Brown University, which is the birthplace of MathWhiteboard. Don is an accomplished speaker and researcher. We are most fortunate to have Don with us today to share the masterpiece known as MathWhiteboard, which is the first collaborative whiteboard designed specifically for mathematics teaching and learning. So welcome, Don, and thank you for joining us today. And with that said, I do want to hand over the screen sharing to you, Don, and let you begin today's presentation. I'm going to stop our screen share here. There you go, Don. You should be in control.
Great. Doug, thank you so much for inviting me today to present. I'm thrilled and honored to be able to present to you and your colleagues. What I'm going to do is I'm going to share my screen because I have a couple of, I am sharing my screen already. Great. I've got a couple of slides here I just want to present to the group. And let me just move my Zoom window out of the way so that I can present it. So I happen to be the CEO and one of the co-founders of a company that makes a product that's called Fluid Math, and as we'll be talking today about a product called MathWhiteboard, they are very related products as I will describe in a moment. We believe that MathWhiteboard is the very first collaborative whiteboard designed specifically for mathematics teaching and learning. As Doug has mentioned, MathWhiteboard stems from some research work that was done at Brown University. That's where I did my Ph.D. in computer science, and my team, we all did our graduate work in computer science at Brown, and the research came out of a research lab that focused in the areas of computer graphics and user interfaces and educational technology. The research, while it was at the university, had been funded by federal research grants, and we as an organization have been very fortunate to have received federal funding from the National Science Foundation, the U.S. Department of Education, and the National Institutes of Health to take what was a nascent research project in a research laboratory and bring it into the marketplace as a tool for teaching and learning that's available for teachers around the world. We've been very fortunate also to have received many industry awards. One that we're very proud of, you can see listed on my PowerPoint slide here, is recognition as a success story from the U.S. Department of Education. And a lot of the technology that I'll be showing you today is also part of our intellectual property portfolio, which is patents and so forth. And as I mentioned, MathWhiteboard stems from another tool called Fluid Math. Our organization has been around for a little bit more than 10 years. The name of the company is Fluidity Software. You can see that on the slide here. And we've just launched the MathWhiteboard product or offering several months ago, but our company's been around, as you can see on the slide here, for a little bit more than 10 years. And we sell another product called Fluid Math, and Fluid Math has some additional functionality beyond MathWhiteboard, but the focus for my presentation here today will be the MathWhiteboard tool. Now, just before I jump into the presentation, I just want to make a couple of comments. I know this is the network of assistive technologists, and typically, you're looking at things from an assistive technology perspective, and the technology that I'll be presenting today is a bit of a new paradigm with regard to technology, and in particular, it introduces digital inking into the teaching and the learning space for mathematics. And it's kind of a different way of interacting with the computer, that is digital link. And you'll see that as I proceed here. And as I mentioned earlier, we're a very research-based organization. So this product is under constant development, and we're always expanding its capabilities, not only in the breadth and depth of mathematics capability, but also in capabilities for particular groups of users. And we're always eager to expand its capabilities, especially in making it more accessible. So one of the goals for us is to make our tool more accessible, and the opportunity to present to you all is really great, because I'm hoping that we can get some really great feedback on how to address the issues needed within the community, but also from perhaps from a research perspective. As I mentioned, we're a research organization, so there may be new ways in which to utilize our technology for folks with special learning needs, and in terms of building, whether there are assistive technologies that we can also already leverage, or if new assistive technologies need to be developed in order to make what we're building be a really great tool for teaching and learning of mathematics for those in need. So let me jump in and show you what MathWhiteboard is all about. I'm going to drop my PowerPoint slide down there, get rid of this for a moment as well. So on my screen, I have two browser windows that say MathWhiteboard on them. And I don't have two browser windows on the page because I'm trying to double up on the promotion of MathWhiteboard. Instead, it's because at some point during this presentation, I will be showing you that MathWhiteboard can be a shared synchronous space for communicating mathematics. So a couple of other things to note about MathWhiteboard before I jump into showing you what it's all about. MathWhiteboard is a free system. It's just a website you go and you use. And I also call it a barrier-free system because MathWhiteboard does not require any accounts or subscriptions or logins or passwords. It's just a website you go and you use. It also is it's a website that runs on any type of device. Now, I happen to be using a Windows Surface, a Windows tablet device where I can write on the screen a lot with my stylus or touch the screen with my finger to manipulate things. But we also have a keyboard-based interface that's just as effective as writing on the screen, that allows me to enter math notation as well. And as I mentioned, it runs on any device. So whether you're using a Windows device or an iPad or a Chromebook or a MacBook, it runs pretty much everywhere. So let me jump in and show you what MathWhiteboard is all about. I'm going to open up a MathWhiteboard here. And oh, by the way, I'm going to turn off my my video, my web camera, because as I'm demoing MathWhiteboard, my face gets very close to the screen, and you probably don't want to be looking at the deep, dark details of my face as I'm demoing here. So I'm going to turn off my webcam, and now I can show you what MathWhiteboard is all about. So think of MathWhiteboard as like a smart piece of math paper. For example, I can write math, 1 + 2. That's pretty simple math, but you'll see it recognizes what I write, and I can get an answer. 1 + 2 is 3. I can change the math, and the answer updates dynamically. I can change this 2 again to a 3. 3 + 2 is 5. I can change this 3 over here to an A, and then I can assign a value to A. So when A is equal to 1, A + 2 is equal to 3. I can change the value assigned to A from a 1 to a 2, and again, the answer A + 2 updates dynamically. I can change this value over here, 2, to a 3, and the answer A + 2 updates, or I can change it to a B, and then I can assign a value to B. So when A is equal to 2 and B is equal to 3, A + B is equal to 5. Now, I can also write more mathematics on the page, maybe A - B, or A times B, or A over B, and I can get answers for all of these math expressions as well. Now, underneath the hood, we have a very powerful computer algebra system that allows me to do some very simple numeric arithmetic that you've seen me do so far, and some algebraic arithmetic like you see on the page here, but I can also apply this at more advanced levels of mathematics. In this case, maybe some calculus. This is a definite integral. And of course, we can get an answer for that as well. So when I go back and I change the value assigned to A from a 2 to a 6, all of the answers on the page update dynamically. Or if I change B to a 7, again, all of the answers on the page update dynamically. I can even assign to A an expression like x plus 1, and now x plus 1 substitutes for A across the page. So the learning of mathematics, in the learning of mathematics, it's very important to be able to see connections between things. Here, we're looking at the relationship between a couple of variables, A and B, with respect to some operators, plus, minus, divide, and so forth. In algebra-oriented topics, we look to see connections between additional things like graphs and tables and solutions. So let me show you a math expression that most folks are pretty familiar with. This is called the slope-intercept form of a line equation. M is the slope, B is the y-intercept. I've just written it on the page, y equals mx plus b. It recognized what I wrote because you can see underneath my handwriting, there's a typeset version of it. So it recognized what I wrote. And with a simple gesture, I can create a graph. I'll do that again. With a simple stroke of my pen, just a swoop, I can create a graph. And now I can pinch and zoom that graph. If you're a math person, you might notice that we have selected a default value for M and B of 1 because the plot that's graphed here has a y-intercept of 1 and a slope of 1. But I can change that. I can make M equal to a different value, like 2, and the graph updates dynamically. Or if I change this value to a 3, again, the graph updates dynamically again. I can be more interactive by creating a slider for M. Let me create a slider for M. This allows me to show very visually what slope really represents. What slope? So I'm varying the value of M, and you can see in the graph on the right-hand side that the graph is updating dynamically as I change the value in the variable in the slider. When the slider is negative, when M is negative, the slope of the line looks like that. When the M is positive, the slope of the line looks like that. B is the y-intercept. I'm going to create a slider for B again here. When in MathWhiteboard, the way you create a slider is when you have an assignment like a variable equals a number, in this case, B equals 1, you draw a straight line down from the assignment, and I'm going to admit that person to the room. Let me do that again. So I created a slider for M, and now I'm going to create a slider for B, a straight line down from the equal sign. We've got a slider for B. Now, when I change the value of B, it's not completely clear what's going on in the graph over there. I see the graph moving, but what are we really changing? Well, we're changing this point. This is called the y-intercept, 0, B. When I graph this, we can now see what B really represents. It's that blue dot. It's the point where the red line passes through the y-axis. That is called the y-intercept. So there's something I say often, and I think it's really important. Learning mathematics is about seeing connections between things. Here, we're looking at the relationship between an algebraic expression, y equals mx plus b, and a graph that represents that in a 2D coordinate plane. Often in the mathematics classroom, the math teacher, the math student, the mathematician uses a primary workspace for doing mathematics. That's paper and pencil. We also use these complementary or secondary workspaces like a graphing calculator or a computer where we're looking at graphs and tables and diagrams and solutions. But all of a sudden, we've got these multiple workspaces that are far from each other and they're disconnected. How do you see the relationship between what you've written on paper and what you see on the screen of a graphing calculator? Right? Those two workspaces are far from each other, and you're using different interfaces to interact with them. On the paper, you're using a pencil. With the calculator, you're using a keyboard. So we've got these multiple workspaces that are far from each other, not just physically, but also cognitively. So what we try to do with MathWhiteboard is bring together into one workspace all of these mathematical representations, allowing the user to move very fluidly between them, and then hiding behind the scenes all the technical stuff. So let me show you another example that really demonstrates this concept in a very powerful way. And the concept I'm talking about again is the concept of being able to see connections between mathematical representations. So I'm gonna clear the screen here, and we're gonna look at what we call a related rates problem. We'll take a look at two cars. Those are two cars. And I'm not an artist, so you might be giggling at my cars, but those are cars. So we'll say this is car A. Label the cars, car A and car B, and we'll give length to the road. And we'll say that car A has a constant velocity of 80 miles an hour. Or in mathematics, we would say the location of car A along the x-axis is defined by 80 units of distance per unit time. Car B is a police car that has to accelerate to catch car A. We use a quadratic to describe constant acceleration. The quadratic is just really the squared that you see there in the expression. So in MathWhiteboard, we have this ability to connect hand-drawn sketches with handwritten mathematics. It's called math sketching. Under the More menu, I can turn on math sketching, and I get this little slider that pops up. And you'll also notice that the mathematical expressions become color-coded, and they are color-coded the same as the labels that are on their respective cars. So to the right of this little slider that pops up, you see some player controls. When I press the play button, you can see the cars moving across the screen in an animated simulation as described by the math I just wrote on the page. I'll do that again. So I press the play button and the cars move across the screen. Pretty cool. Pretty cool for us as adults. Imagine what happens when you show this to kids in the classroom. Their heads explode. They start asking really great mathematics questions that require knowing more math in order to answer the question, like, can you make the car go faster? Or can you make the car bump up and down? All of a sudden, the students are engaged and they're asking really great questions. But from a high-level pedagogical perspective, really what's happening here is we're making a connection between this very abstract algebraic notation we see on the left-hand side and a very concrete example from the real world that we're all familiar with. Everyone knows about cars driving down the street, especially kids in high school. So that's where learning happens in the math classroom. When we learn that abstract stuff we're learning can be applied to the real world. And in the case of algebra, it can be applied in so many different things that we do in the real world. Now, of course, that's a very high level pedagogical perspective on what you're seeing on the screen here. From a very practical perspective, this is again called a related rates problem, and related rates problems show up on standardized exams all of the time. And typically they come with a couple of questions. The questions usually are, at what point in time does something happen? Or at what point in distance does something happen? Here, the question is, when does car B overtake car A? And we can see from the simulation it happens right about there. Well, that's a math observation, not a math answer. We want to get the math answer. How do we get the math answer? Well, there's a couple of different ways to get the math answer. One way is, if you're a math person, you know that this is also called a system of equations. And with systems of equations, we can set them equal to each other and then solve. And of course, we have this very powerful computer algebra system underneath the hood, and I could use that to solve this immediately. But the way I like to solve this problem really is through exploration, and it's something analogous to the scientific exploration. What we're going to do is we're going to graph these functions. We'll take a look at, we'll try to come up with a hypothesis, and then we'll use the hypothesis to test if it's correct, and then we'll apply that hypothesis to prove if it's correct as well mathematically. So I'm going to graph these functions, and oh, by the way, to graph those functions, I drew one graphing gesture, one swoop through both of these functions, and now I can, oops, I want to do that with the math pen. Now I can pinch and zoom the graph, and we can look at at the graph and notice anything interesting. And of course, with systems of equations, the things that are interesting are usually points of intersection. So we can see one point of intersection at the origin. That's where the cars start. And then one point of intersection out here in the quadrant, and that's where we can see in the graph, the quadratic overtakes the linear. But that's also where we hypothesize that the accelerating car, car B, will overtake car A. And we can see that point of intersection happens at about 8 units of time and at about 650 units of distance. So that's our hypothesis. When time equals 8, the car should be at the same spot, and that spot should be about 650 units of distance along the road. So let's test the hypothesis by running the simulation again. So I'm just dragging the slider over here, and I'm going to move T over to 8 in the slider. And we can see the cars are at about the same spot. And, we're just eyeballing the simulation, and we're eyeballing the graph. So we know we're on the right track, but we haven't proven anything yet. So let's prove this. The way we prove things in algebra is through substitution. So I will substitute in the value of our hypothesis when time equals 8 to see if the location of car A along the x-axis is what we think it might be from the graph, 650 units of distance. Let's see. Okay, so A sub x when time equals 8 is 640. If B sub x is also 640, then we have proven the hypothesis. Cool. So I love this example because it demonstrates the power of having multiple mathematical representations in one workspace, and everything is connected. So, you've got the algebraic representation, you've got a simulation, you've got a solution, you've got a graph. You could look at a table of values, and everything is connected. So when the student said, hey, can you make the car go faster? Well, we can change the 80 miles an hour to 90 miles an hour. And then look, all of a sudden, the graph changed. The point of intersection just moved. We can see right there in the graph. The solutions also changed as well. So I'm going to check. I see there are some comments in the chat. I just want to see if there are any questions. And if you have any questions, feel free to interject. Please put some questions in the chat here as well.
Yes,
let me just see. Oh,
Anne's got a question in here. Yeah, Anne put in a question. She's hoping that she'll be able to address some of the accommodations that might be able to be made for those who are visually impaired or blind, regarding how the tool reacts to magnification, contrast, and screen reader usage, and things along those lines. So I'm not sure if you're able to address that at this point, Don, or if you wanted to leave that until a little later.
Sure, Anne, that's a great question. As I mentioned earlier, we're eager to address some of those issues. We have not addressed them as the system stands on its own. I know there are some facilities within, say, Microsoft operating system that allow you to change the contrast on your screens and so forth, but we have not yet had those built into our system. But we are addressing that. I think we're addressing the contrast issue very soon. So what you might see is a high contrast version of MathWhiteboard or the Fluid Math system soon. But in terms of screen readers and magnification, those are not yet something that we have addressed. And of course, it's a little bit challenging, I think, because this is handwritten math notation. The screen reading of handwritten math notation, of course, is challenging, but the really great benefit that we have here is that we're recognizing all of this handwritten math notation as actually typeset math notation. So it's probably feasible to be able to take this typeset math notation that we have stored within our system in various representations, whether it's MathML or LaTeX, and feed that into a screen reader such that a narrator would be able to read it back to someone with a vision impairment. There was another question about voice control technologies for students who do not use a mouse. That's a great question as well, and we have not taken that into consideration at the moment yet either. And of course, I think that from my perspective as a researcher, I look at that and I say, what a great opportunity, because those are, I think, some of these things are things that have not yet been necessarily solved in particular for mathematics teaching and learning. Now, it may be the case because I'm not an expert in the area, but the recognition of spoken mathematics notation, I'm not sure if there's a system for that. There may be, and I'd love to learn if there is, and if there is, then perhaps it's an easy integration for us to make. But of course, mathematics notation is unique because mathematics notation has a spatial relationship between the symbols and the characters, and expressing that verbally, of course, is a challenge, and it's a challenge we should look toward as something that is solvable. But thank you; those are really great questions. So let me continue on here. There's another bit of functionality that I think is pretty unique to MathWhiteboard that I'm not sure you'll see in any other system. And it continues along with this vein of being able to see connections between things. So I'm going to start up a new MathWhiteboard here. And this bit of functionality allows us to see connections between equivalent expressions on a page. So under the More menu, I can turn on Highlight Equivalence. And what this will do is it will highlight any equivalent expressions the same color. Let me show you what I mean. So for example, the number 3 and the number 2 are not equivalent. So they're color-coded differently. And the number 4 is not equivalent to 3 or 2. So again, it's highlighted a different color. But 6/3 is equivalent to 2. Oh, I misrecognized my 6/3. I want that to be 6/3 here. Oh, let me rewrite that. Every once in a while, it's a little tricky getting to recognize it to work. But 6/3 is equivalent to 2. So it's color-coded the same as 2. And 4/2 is equivalent to 2. So now it's color-coded the same as 2. Now you can imagine using this color coding functionality at the lower grade levels where we might be looking at equivalent fractions and equivalent decimals. Let me show you an example. So let's say we have these numbers spread out on the page, and maybe we will add some more numbers. And I'm going to turn off highlight equivalence to start with. I'm going to add some more numbers to the page. Maybe we have the number 5, and we have the number 10/2, and maybe the number 20/4. You can imagine the game at the lower grade levels where the goal is to match these numbers up to see what's equivalent and what's not equivalent. So maybe right off the bat I would connect the the 4/2 and the 2, and maybe the 20/4 and the 10 because they kind of look similar. But I don't know about 5. That's a little weird because it doesn't look like anything else. And 6/3, that's an oddball as well. I don't know. So let me go and turn on my highlight equivalence and see how well I did. So I turn on highlight equivalence, and you can see, oh, well, I got these correct over here. And I got these correct, but the 5 over there, I didn't realize. Oh man, it's connected to these two. Oh, that's because they're equal. And the 6/3 should be over here as well. So you can imagine using this at the lower grade levels. But this can also be applied at the higher grade levels where we're looking at algebraic equivalences. So for example, we might have some algebraic identities. So a plus b and b plus a are equivalent. So they're color coded the same. But a minus b and b minus a are not equivalent, so they're color coded differently. And then a times b and b times a are equivalent, so they're color coded the same. And then a over b and b over a are not equivalent, so they're color coded differently. This can also, so far you're seeing me apply this equivalence highlighting at the numeric, for numbers and so forth, and for algebraic identities. It can also be applied at the much higher grade levels where we might be looking at things like trigonometric identities. So tangent of theta and sine of theta are not equivalent to each other, so they're color coded differently. But sine of theta over cosine of theta is equivalent to tangent of theta. That's an identity. So now they're color coded the same. Pretty cool for testing equivalent expressions on the page, but perhaps the most powerful way in which to use this color coding functionality is in step-by-step problems. You all may remember step-by-step problems. Maybe they were the bane of your existence when you were taking math classes. Maybe they were a fun puzzle for you to solve. But either way, sometimes they're pretty challenging. And I think this is a pretty interesting application of the color coding that we're looking at here. So I'm going to take a look at a very simple example. So if we had this math expression, 2x plus 3y equals 4. If we were to solve for x here, we might start by moving the 3y over to the other side of the equal sign. So let's do that. So the first step here might be 2x equals, and then 4, and then we're moving the plus 3y over to the other side, right? So this is going to be plus 3y. But wait a second, it's not color-coded the same as the original statement. We know that every step in the step-by-step problem should be algebraically equivalent to any other step, but these are color-coded differently, so I must have made a mistake. Gee, what did I do? Well, you may know, or you may have noticed, that when I moved the 3y across the equal sign, I should have changed the sign in front of 3y. It should have gone from plus to a minus. So when I change this plus to a minus, all of a sudden, that first step becomes color-coded the same as the original statement, and now I know that I've done the step correctly, and I've done the calculation correctly, and I can comfortably move on to the next step. So now the next step, of course, is x equals 4 minus 3y over 2, and that's now color-coded the same as the two other steps. So now I know that I've gotten the solution correct. I think this is really interesting because we're doing a few things here. Number one, we are giving immediate feedback to the student who's solving these problems. We're not telling the student what the answer is. We're just giving feedback. Did you do the calculation correctly or not? The other thing that's really interesting here is that as we move along in mathematics, some of these step-by-step problems can become very lengthy. They can be 10 or 15 steps long, and the students can be investing lots of time. It can take 10 or 15 minutes to solve some of these problems. And for students who are struggling, it can be very discouraging to get to the bottom, to get to the last step, only to realize I got it wrong. And to look back at that 10 minutes that you invested and say, and all of those steps that you see on the page in front of you and say, oh man, where did I make my mistake? I don't know where. There's so much math on the page. I don't know what I did wrong. Should I start over again and just start from scratch? Or should I try to spend all my time looking through this to try to figure out what I did wrong? Or should I just forget it and move on to the next question? So again, what we're doing here is we're giving that immediate feedback to the student, which we think is very helpful. So I'm going to pause yet again for another moment to see if there are any questions in the chat. Oh, a very nice comment. Thank you very much. Yeah, we're pretty psyched about the tool and its opportunities for use in the math teaching and in the classroom. So let me continue on here. So one of the really useful bits of functionality for MathWhiteboard here is that the MathWhiteboard can be a shared collaborative page. So I'm going to create just a new MathWhiteboard on the right-hand side here. And as I mentioned earlier, I have two MathWhiteboard web pages up on the screen here because I want to show you how the pages can be shared synchronously. Every MathWhiteboard has a unique URL. You can see that in the browser window here. And when I click copy link, that will copy the URL to my clipboard. And then I can paste that URL into a learning management system, whether it's Microsoft Teams or Google Classroom or Schoology or some learning management system or a course web page, or I can put it in an email to a student. So I just click copy link and that copies it to my clipboard. I am going to just paste that into the web browser on the left-hand side here. And now these two web browsers are sharing the same MathWhiteboard. And really what's happening here is I'd like you to think of this as two different users or on two different computers, not necessarily in the same room because they're connected via the internet, being able to share the same collaborative math page. So when the user on the right writes something on the page, it shows up in real time immediately on the left-hand side. And when the user on the left edits it, so I wrote that originally on the right-hand side, now I can edit it on the left-hand side. Both users see the changes at the same time. Now, all of those mathematics resources and tools that I've shown you so far are available. So we can create graphs, and we can put sliders on the page, and we can, put solutions on the page as well. So when one user makes a change on one side, the other user on the other side sees it as well. And by the way, it doesn't have to just be two users. It could be multiple users. So in this case, maybe it's one student working with a teacher. When the student on the left makes a change to the graph, the teacher on the right can see that change in real time. So it's an interesting environment, especially now with the pandemic and all the online learning that we've had to experience. What we've learned is that teaching, and perhaps I'm biased, but I think teaching mathematics is especially challenging online because communicating mathematics synchronously online is challenging. There are many whiteboarding tools out there that are just kind of blank pieces of paper that you can write on, but none of them have mathematics functionality built in as first-class objects. So oftentimes we want to be able to see, as I've mentioned, those relationships between mathematical representations. And if you can make those relationships displayed really quickly, then it's really effective for the learning process. By the way, these math whiteboards can have multiple pages. So on the right-hand side, I've just opened up a little slide sorter on the left of the browser window. I can click the plus button, and that will add blank pages to my math whiteboard. Or I can just click on one of the pages, hit Control-C, and then Control-V a few times, and I've got multiple copies of that page. Now, what we've learned during the online learning environments that we've seen ourselves in is that some math teachers have been very creative about this bit of functionality. What they've been doing is they've been assigning groups of students to each of these pages. So for example, on page 2, they might assign group 2. And on page 3, they might assign group 3. And on page 4, this might be group 4. So let's say, for example, that this user on the left-hand side, this is a student who, maybe it's two students, maybe it's Mary and Billy working together on the left-hand side here. So I'm going to turn on my draw pen and make it green over here. So maybe Mary and Billy are going to use the green pen to write their math on the page. So Mary writes some math because Mary's pretty diligent. And you can see the teacher in real time can see that on in that slide on that page. Now, perhaps Billy is goofing off, so Billy is drawing smiley faces on the page. So, and again, the teacher in real time can see what's happening on any of one of these pages. So it's really an interesting way in which for teachers to have students working collaboratively in groups while being able to monitor their work in real time. So continuing on here, a couple more bits of functionality I want to share. I'm going to create a new math whiteboard on the right-hand side, and I'm going to dismiss the window on the left. So oh, by the way, please, if you have any questions as I'm plugging along here, please let me know. One of the things that math teachers especially are very well known for is having lots of PDF files, lots of worksheets, and they store them in folders on their computer, neatly organized into topic areas and so forth. I have a folder with 9 or 10 worksheets here. I'm going to open up one of these solving systems of equations. I'll just open up this worksheet here. And this looks like any other math worksheet. It's a PDF file that normally we would print out on paper and hand out to the kids. But with Math Whiteboard, we can take any PDF file. So I can take this PDF file and I can drag and drop it right into the Math Whiteboard space. And then all of a sudden, that PDF file becomes the background for my Math Whiteboard, upon which I can do all of my cool Math Whiteboard stuff, like write math on the page. I can put graphs on the page. I can put solutions. I could use that color coding stuff if I wanted to. We can work through these problems. And by the way, this could just be used as a PDF annotation tool. I just turned on the draw pen here, and the draw pen just lets me annotate the PDF document, right? I can change the pen colors. Maybe I want to mark this up over here as well. And I'm going to put some arrows on the page. So what was a static PDF file that we printed out on paper and handed out to our kids now becomes a live, interactive, dynamic mathematics web page that can be shared synchronously between users, as we just saw earlier, as a real-time shared workspace. And by the way, you don't have to do all the math if you don't want to do math on the page. You could just use this as a PDF annotation tool. And it does not have to be a math worksheet. It could be any type of worksheet. It could be a history worksheet that you just drag and drop in here, because we have all these annotation tools that allow you to just mark up the page. And also, this Math Whiteboard was a multi-page, I'm sorry, the PDF file was a multi-page PDF file. And each page of the PDF file is imported as a separate page in Math Whiteboard. Now it looks like there's a couple of questions here, so I'm going to turn on the chat here, see what the questions are. Let's see here. First question is, in introducing this tool, some faculty will ask, is there a way to work asynchronously using the tool and save progress? So that's a great question, and there's actually several answers to that question. So I'm going to share the multiple answers with you. The first way to do this is, as I mentioned, every Math Whiteboard has a unique URL. You can see that in the browser window up there. I'm just going to create a new Math Whiteboard here, and this Math Whiteboard over here on the right hand side, we might want to create an activity. So maybe we'll create y equals mx plus b, and we put a graph on the page here, and then maybe we'll create a slider for m. And sometimes this question comes in the form of, I'm a mathematics teacher, and I teach 4 periods or 5 periods a day, and I want to use the same activities period after period because I'm teaching the same class. And what I want to do is I want to be able to have that activity and then reuse it. So as I mentioned earlier, every Math Whiteboard has a unique URL. On the left-hand side browser window, I created another Math Whiteboard. This is just you can see it's a different URL up here. So with Math Whiteboard, you just saw me moments ago make a copy of a page. So I hit Control-C there, and I pasted it within the same Math Whiteboard. But you can also paste that into other Math Whiteboards that you have available on your screen. So I just pasted that on the left-hand side here. So this is essentially a copy of that Math Whiteboard that we had on the right-hand side, but now it's on the left. And you can do this if you want to create like a master and then use it several periods in a row, or if you wanted to have a master copy and then share it with groups of students or individual students, you could do it that way. That's the first answer. Within Math Whiteboard, you can do it. Another way to do this is, I mentioned earlier, we have another product called Fluid Math, and the Fluid Math system I mentioned we've been selling for a while, and Math Whiteboard is actually a component within Fluid Math. So Fluid Math layers on top of Math Whiteboard accounts and subscriptions and logins and so forth. So if it was really important to you to be able to save these things, you can have a Fluid Math account and save them. And because we've been asked this question so often, we just recently built an integration between Fluid Math and Math Whiteboard, where you can save your documents within Fluid Math and then share them really easily with the click of a button as Math Whiteboards. So it's a really easy way to make these things and then keep them in Fluid Math, but then be able to share them whenever you want, make copies of them and share them in Math Whiteboard. So the next question is, are students or teachers able to save and print out pages for later documentation for parent meetings and student review meetings? So that's a great question too, related to the previous answer that I just gave. So one way to do that is to use Fluid Math. So students can also have Fluid Math accounts. Fluid Math layers on top of MathWhiteboard some additional functionality that enables creation of assessments, and it adds actually some very cool functionality that enables automatic grading of those assessments. And when you think about this from a high level perspective, really what we're doing is modeling the paper and pencil paradigm that we all knew. A lot of online environments for mathematics teaching and learning right now are such that there's a question and a multiple choice answer, and you pick the answer, and you don't really get to show your work. But because we're modeling paper and pencil, the students get to show their work. And in the Fluid Math system, the students could show their work and then submit it to the teacher, and then the teacher can mark it up and give feedback and then send that back to the student. Of course, in the Fluid Math system, the students and the teachers need accounts. Now, with MathWhiteboard, the other answer to your question here, Anne, is that these MathWhiteboards can be printed. So from the browser window, we can just go to the print option, and these we can save as PDF. So I can pop up print and then save as PDF, and I can specify the landscape or the portrait. Because these MathWhiteboards can be expandable pages, you may want to specify the zoom level when you're printing as well. Let's see, another question here. I can see the benefit to teaching and learning, but imagine instructors may not want students to have access to autographing if that is something they are being assessed on. So can any of these tools / functions be turned on and off? That's a great question. During assessments, you can turn off some of the functionality when it's just a MathWhiteboard. So MathWhiteboard is, there's no assessments happening. The Fluid Math system provides that functionality for doing assessments and so forth. Now, if you're looking at MathWhiteboard as, an environment where students can explore mathematics, but you're concerned that, oh man, they're going to get to the answers or they're going to get to the graphs very quickly, that's a challenge that every math teacher faces these days, because the tools that are available ubiquitously on your phones and your computers are really powerful. So there are applications that allow you to take a picture of your math question and they'll give you the answer. There are other websites where, like Wolfram Alpha, for example, where you can basically type in any mathematics question you could ever conceive of, and it will not only tell you the answer, it'll tell you how to solve it, and then it'll give you a whole bunch of research papers on the math topic area. It's a really awesome site, but again, really powerful from the perspective of students have these tools at their fingertips that they can leverage to get to answers really quickly. And of course, that's a challenge. And I think what it also makes us all recognize is that the way in which we teach mathematics sometimes has not yet caught up with technology. So we, to a certain extent, have to think a little bit more deeply about how math is taught in light of technology being ubiquitous. So a really great question. Thank you very much. Oh, another question here. Oh no, I think that was it from Maureen. Thank you, Maureen, for the question. So let me continue on. There's a couple more things I'd like to share here. So I mentioned early on that everything I've done so far with my stylus or my finger and with the touchscreen can be done just as effectively with a keyboard and a mouse. And I'm going to show you that now. So far you've seen me using the draw mode up here to draw things on the page. So you might draw a smiley face on the page with the draw pen. And I've used the math writing mode over here to write math. So here's some very simple math. You would not use the math writing mode to write a smiley face, because that's not a math symbol. Maybe it should be a math symbol. I would be in favor of that, but it's not currently. But MathWhiteboard tried to recognize it as a 0, and of course it's not 0. It's not a math symbol, so it's not. You wouldn't be using the math writing pen to write smiley faces. But in the middle up here, there's a math typing mode. When I turn on the math typing mode, I can type math on the page. And before I type math, I'm going to turn off the highlight equivalence. Even though that works with typing, I just want to turn it off because visually we want to see the math here typed. So, so I can type math. I'm going to type a math expression. Y equals ax squared plus bx plus c. So I've just typed this math expression. But you know what? Not everyone knows how to type math with their physical keyboard. I'm using my laptop keyboard to type that math expression, but there's no x squared key on my laptop. How did I type that? Well, I happen to know the control sequence, but not everyone knows the control sequence or the keyboard shortcut to give a superscript like this. So we also have down at the bottom of the page, we have a what we call a virtual keyboard. It's kind of like a pick and peck keyboard where I can, press the buttons on the screen, and then the math expressions will show up as I pick. So I can say y equals x squared, right? So now I've used the virtual keyboard, the calculator style keyboard at the bottom of the screen to type in a math expression. Now, for first-time users, sometimes they try to use that swooping gesture to create a graph here, but you don't use that with typed math. Instead, what you do is you go to the Insert menu, select Graph, and that will put an empty graph on the page. And now we can drag and drop those math expressions that we typed into the graph area, and they'll be plotted for us. And A, B, and C within this math expression are clickable, so I can click on A, I can click on B, and I can click on C, and now all of a sudden I've got sliders that allow me to manipulate very dynamically the values of these various parameters. So I'm changing A and I'm changing B here. Now, of course, sometimes you may want to have your typed math on the page because maybe your big, ugly handwritten math doesn't look so good, or maybe it takes up a lot of space. So underneath my handwriting, that's actually a typeset version of my handwriting, and it's also a button. When I click that button, my handwriting will go away, and I'll be left with just the typeset math. So I'm going to do that right now. I click the button, and now I've got the typeset version of that math expression on the page. And I can drag and drop that into the graph area, and we've got a graph of that y equals mx plus b in the graph area. By the way, there's another gesture. I can draw a big plus on the page. That'll put a big empty graph on the page. And I could have graphed this math expression in a separate graph area as well. And there's one B slider on the page. So when I change the value of B, everything associated with B on the page updates dynamically. Now, let's go back to this concept of having a more well-formatted page for our students. Maybe we want to include some instructions on the page. So up here in the menu bar, we have a text box button. When I click the text box button, I can now type some instructions on the page. So let's type some instructions. I'll say play with the sliders to understand the transformations. Okay, so I put some instructions for my students. But these text boxes are actually really cool. I can do some interesting things. One of those things is that I can embed a YouTube video in them. So I have queued up here in this browser tab, I have a Salcon video about Salcon talking about quadratic equations. And as you know, with all YouTube videos, you can click on a share button, and that share button will allow you to make a copy of the URL, the link for the YouTube video, or I can get the embed code. So I can click on embed, click copy. Now that copies the embed code to my clipboard, and now I can go back to my MathWhiteboard, insert that embed code into my text box, and all of a sudden now I have got a YouTube video embedded in my MathWhiteboard. And by the way, this YouTube video is embedded, which means that it's running there in place in the MathWhiteboard, rather than having it be a link where I click on it, it opens up in a different tab or a different browser window. Instead, we want it to run in the same workspace. And as I mentioned much earlier, it's really important to be able to have all these mathematical representations in one workspace versus having to move between tabs and devices and browser windows, because when we start doing that, we start losing the connections between things. So we want to keep everything in the same workspace so that the students can see the relationships between all of these representations. So let's see. I've run through a lot of the functionality of MathWhiteboard, and I'd love to hear any feedback that you might have about what we're doing and how it might be either applicable in your environments or the work that you do. So please, if you have any questions, please let me know.
Yes.
Or post them into the chat window. That would be great.
Great. Thank you so far, Don. This has been fantastic and eye-opening and confusing all at the same time. But that's speaking to somebody speaking here that doesn't have the ability to do 2 + 2 on some days, most days. So just want to remind everybody, as Don was saying there, is to add your comments or questions into the chat as we go. If anybody would like to ask their questions by voice, please do unmute your microphones and we'll call on you. And I see that Lyle has done that. So go ahead, Lyle.
Yeah, thanks. Don, your app had me at hello, seriously. Wow. Where has this been? I would have loved to have had this when I was working with my son in his first quadmester of math. And it was funny because just this morning, I had a student and I was using the Zoom whiteboard, which is not the best whiteboard to do math in. I wish I saw this from yesterday. I know my nerd is showing, but amazing tools like this really excite me. I might have missed, in my eagerness to share this with my fellow adaptive technologists, I might have missed this, but does the tool incorporate a solution steps functionality like Microsoft Math or Photomath? And lastly, I just want to say thank you to you and the team for producing such an amazing product. Thank you, Don.
Oh, Lyle, thank you very much for the question and the feedback and the encouragement. We thrive off of that, so thank you very much. With regard to your question, I did not chat about that, and we have begun to work on a little bit of functionality related to that, and I'll show you very quickly. So if I had, we'll go back to that example that I had before, where we had 2x plus 3y equals 4. If I right click on any math expression, actually, you know what? Let's do a simpler one. Let's do 3y equals 4. You know what? Let's do 4 plus y. Okay, how about that? That's pretty good. So if you right click on any math expression in MathWhiteboard, you can get a hint. So I click on show hint, and it will give me a step. So it'll give me one hint at a time. So it says, step 1, move all terms to the left side. So if I don't really know what that means, I can click show more. And then even though this is a little cryptic, we're currently working on this in terms of functionality. So it's showing us a little bit of cryptic notation here. But what we're really working toward here is a means by which students can have, either a set of hints available to them. Maybe the teacher says, you can do this homework, but you're only allowed to use 3 hints or 10 hints or something like that. So as the hints are being used, the little hint counter is incrementing here. So kind of a cool bit of functionality that will kind of align with some of that functionality that you might have seen elsewhere. Great question, though. Another bit of functionality here that's useful. While I showed that, I noticed there was something else I wanted to share as well. One of the challenges that math teachers face is creating assessments for their students where entering math notation in a word processor is challenging because you have to use these equation editors that are sometimes difficult to use. So in MathWhiteboard, you can write, when you write any math expression, I'm just going to write one that might be a little bit difficult to type into an equation editor. So let's do like a plus b squared. And the reason this might be difficult to type, I didn't recognize that. Let me see if it does this better here. Oh, no. Let's see if it does that better. Okay, that's better. So one of the reasons this might be tough to enter with an equation editor in like a word processor is that, there's lots of different symbols here, and there's a spatial relationship between the symbols. There's a fraction and a squared and so forth. So if I right click on any math expression in MathWhiteboard, I can get various typesetting formats for that. So one example is presentation MathML. That happens to work really well with Microsoft Word. So when I click copy presentation MathML, that copies the MathML to my clipboard, which I can then go into my Microsoft Word document, and then I can just hit Control V and paste that math expression here. And by the way, it's editable within Microsoft Word, so I can just cursor through here and I can change that denominator to A+3 instead of A+B. So kind of a cool functionality that potentially was beneficial for math teachers who create lots of assessments. Let's see, any other questions at all? Great question about chemistry there. It's funny, I often hear chemistry teachers tell me that chemistry is really just algebra. And to a certain extent it is. It's like an algebra course because it's oftentimes, or sometimes, it's about balancing equations. If you've taken a chemistry course, even through like Chem 2 in college. I remember when I took Chem 2 in college, it was all about balancing equations. We don't yet do in chemistry, but we have dabbled with that on the research side of things. So in the future, we may do a little more dabbling. Let me see if there are any other questions here. I think that's it for the moment. Any other questions?
There's a note in there, just a quick introduction here. Lori, I see your microphone unmuted. Anne, in case you have to leave or that, I just wanted to bring this to everyone's attention, is that Anne is looking forward to trying this out with magnification software that Anne uses. And Anne, I would almost guarantee you that Don would be very interested in hearing your feedback on that and any input that you might be able to feed back to him. So. Okay, Lori, go ahead.
Yes, absolutely. I would love that. And if you try it with your magnification software, please let me know how it works. I'd love to hear about it.
Don, I was just wondering if there's a way to save these screens. I could see a student wanting to save their work they've done to kind of refer back to for studying for a test or that kind of thing. And then I have one other question. I pulled this up and was kind of monkeying with it while you were showing it to us. And I put it in the math type mode. And when you type it, does it change colors? Like if you, like you showed where on the other one, it would change to a different color if the student made a wrong step and then they'd have to go back and look at it. It didn't seem to do that when I was trying to use the math type mode, and I was just curious if it worked the same way.
Yeah, great questions. The first question was, can you save these? And there's a couple of answers to that. One is, if I have a math expression here and a graph, if I wanted to hand this into my teacher, I could go to the print menu and click print, and this will give me if I save to PDF, this will give me a PDF version of what I have there. So one of the challenges with creating a website and a system where there are no accounts or subscriptions or passwords or logins is that these things don't necessarily associate with an account. So we don't save these things as associated with the account. We do save them because the URLs are all unique, and we don't delete them yet. At some point in the future, we may make things expire. But the other answer to the question is, if you really want saving and loading, and if you really want to be able to submit these things to your teacher, or you want to show your parents, the Fluid Math system has accounts and logins and so forth. So, and it also has this assessment and hand-in, hand-out capability where a teacher can create an assignment or an assessment, hand it out to the student, as a saved document, hand it out to the student. The student does the work and then hands it back into the teacher. The teacher can mark it up and then hand it back to the student, again, modeling like the paper and pencil paradigm. But that's the fluid math system where we have accounts. And by the way, the fluid math system looks a lot like MathWhiteboard. It's just that it's a subscription-based system. And by the way, the pricing there is very reasonable as well, but it's just not free. Now, the other question you had about typing math on the page and the color coding, you had seen me. So under the More menu is where we turn on highlight equivalence. So under More, I can turn on highlight equivalence. And again, things that I type on that I write on the page, like 2 and 3, they're not equivalent, so they're highlighted different colors. But I can also use the typing mode here when I'm in highlight equivalence, and it works the same. So for example, x squared is not equivalent to x plus x, right? So they're color coded differently. And let's see, 2x is equivalent to x plus x, but x squared here is also equivalent to x times x. So you can see how the color coding works with the keyboard entry of math notation as well.
Okay. Lori just says thanks. This is really great. So that's thank you, Lori,
yeah,
for that. And Lyle, you're unmuted again. Go ahead.
Yeah, sorry, no, I'm just looking at all this development and I'm wondering how you make money, Don.
It's the what's the catch? We get that. I get that question all the time. How do we? What's the catch here? So we, our company has kind of taken the opposite approach of a lot of other companies, for better or for worse. A lot of other companies that build technology will offer the technology for, as soon as they build it, they offer it for free. And after they get a large following and a lot of users, they start charging for it, or they start charging for pieces of it, or they charge for upgrades and so forth. In the gaming world, you get the first level for free, but then if you want to go to the second level or the third level, you got to pay for that extra stuff. We took the opposite approach. We started with a product that we sell subscriptions for called Fluid Math. And we just recently wanted to release this portion of Fluid Math, which is the collaborative whiteboard portion, as a free tool, because we recognize that, again, one of the biggest challenges during the online learning environment that we found ourselves in during the pandemic was the communication of mathematics online synchronously with students. So we wanted to provide that as something that that teachers could leverage in a free system. And I try not to kind of upsell people on the Fluid Math system too much, because we think that the MathWhiteboard is very powerful on its own, and it serves its purpose. It's the analogy I use is that it's kind of like your chalkboard in your classroom. You show up in the morning and it's a clean slate. You start using it, and for period 2, it's a clean slate again, and you start using it. If you need that extra ability to save and load and do assignments and assessments, well, that's where the Fluid Math system comes in. So you can save these things, and the subscriptions for Fluid Math are very reasonably priced. I think a one-year subscription for Fluid Math for one person is $15. So what a lot of teachers have been doing is they've been purchasing a Fluid Math subscription for themselves. And we just recently built an integration, because everyone has been asking this question. We just recently built an integration between Fluid Math and MathWhiteboard, where if you save something in Fluid Math, there's a button that you click on, and it can be shared. A copy can be shared as a MathWhiteboard. But good question. Thank you very much, Lyle.
Yeah, and does the Fluid Math have an integration into learning management systems?
It has at the moment a kind of a lighter integration where all of your Fluid Math documents, in the same way that MathWhiteboards each have a unique URL, Fluid Math documents also have a unique URL. So you can copy those URLs and paste them into your your learning management system, like the course web page or an assignment and so forth. As we move forward, we'll probably be doing some more integrations with learning management systems that, allow the teacher to kind of share grading between the systems as well.
Yeah, because I'm just thinking it'd be kind of neat if a teacher could teach through the tool, whether it's Fluid Math or MathWhiteboard, in the LMS, learning management system, and then the session is saved as part of like the instructor notes throughout the semester, so students can always go back to it and review it, unless that's a feature that already exists.
Oh, yes. Yes. One integration that we have coming soon is with Microsoft Teams. So you'll see that coming out soon.
Okay, thank you.
Encourage it.
Let's see.
Yeah.
There was a question here. Is there a demo version available? I would like to include this in a link to the grad course in AT that I teach. So the demo version that's available right now is you go to mathwhiteboard.com. It's just a free site. You go to, no logins or anything necessary. It's just a website you go to and you click Start a MathWhiteboard. That's for MathWhiteboard. Fluidmath.net is the website for Fluid Math. I'll just bring up another browser tab here. I'll type in fluidmath.net, and when you go to fluidmath.net, well, if you're not logged in, I'll log out here really quickly. You can just click the free trial here at fluidmath.net, and that will give you a free trial for Fluid Math.
Okay, great. So just as we do round out the webinar, if anyone has any final questions, thoughts, comments, please enter them into the chat, or unmute yourself, and I'll see you on the list as unmuted, and we'll call on you to voice your question or comment. And Maureen has just asked whether there are demo videos that are available to share with others outside of the replay for this webinar.
Yeah, I was just going to point that out. There'll be a replay for this webinar, but if you were to go to YouTube and type in MathWhiteboard as one word, just one word, MathWhiteboard, you will see a whole bunch of videos of me doing a demo similar to what I've shown you here. Probably not as extensive as what I've shown you here, but there are some really great videos of people capturing what I've done. And we'll be putting up more videos on our YouTube channel as we move along as well, so you can find those there as well. One of the things that I've been chatting with folks about also during my presentations and my demos is that we're really appreciative of folks spreading the word about MathWhiteboard. We're a small ed tech company, so we're kind of really depend on folks spreading the word about what we're doing, especially within communities where there would be some benefit. So, if you happen to know any math teachers, or if you're part of a school district or a school system and you would like to share it, please do. Or if you're part of any professional communities where you think there would be folks who would benefit from it, please share it there. And if you're active on social media and you want to share it, that we're always so appreciative of that.
Okay, so I'm just going to take the screen sharing back here. So as we wrap up here, Don, the fact that just give a few moments here for last minute thoughts or questions, or unmuting of the microphones, just as I begin our wrap up. It's when I saw this tool demonstrated through another one of your webinars, Don, I was floored, well beyond the fact that I didn't understand a single piece of the math that you were demonstrating, and I've just come to understand that that's fact of my life is that I don't understand the math, but I saw the benefit in your tool, and that this has its obvious place for teaching and learning of math. But from an assistive technology perspective, although we've talked a bit about today where it's not necessarily 110% accessible out of the gate in regards to screen readers, magnification, keyboard shortcuts, all of these kind of things that we normally look for, what it very much is the tool it provides the ability for us to be able to differentiate the learning for those people that we support, and sometimes, as well as it gives us the opportunity for the instructors to be able to present math in a different way, and sometimes present it in what could be an accessible way, whereas otherwise math is not necessarily accessible from a text perspective, as you so generously demonstrated there with typing on the keyboard. So being able to use the tool for that as well, to be able to create math expressions in a much easier way than some of the clunky ways that that people are finding themselves using. So there were so many benefits, even though it wasn't a direct piece of assistive technology. It's certainly I wanted it in the toolboxes of the assistive technologists that that are out there, and part of the network of assistive technologists and the wider AT community. So Don, you bringing this to us today and showing it to us is fantastic. There's been a couple, last comments here. Wink found YouTube links that'll work great for her class, so that's great. She's going to be spreading the word, and if you get the information in Wink's hands, trust me, it gets into a lot of other people's hands. Wink is wonderful for that, and as well, she's teaching the up-and-coming assistive technologists out there through her course, so that's great. And Anne says that she can use the zoom magnification, color, contrast, and enlarging cursor and pointer so far. So she's going to be in touch with you about the other features and as it relates to MathWhiteboard. So that's great. Thank you very much for including that, Anne, and sneaking it in under the wire there with us now, knowing that zoom magnification and the other points that you make there are certainly work with the MathWhiteboard. So it's fantastic. So yeah, so Dawn, and before we kind of come to a final conclusion here, any last thoughts or comments from yourself?
No, it's been a real great pleasure. Thank you so much for inviting me. As I mentioned earlier, we're very research oriented. So these are the types of conversations I really love and thrive off of, because they expand the way in which I think. And they give me an opportunity to think about how to apply what we're doing for different communities that could benefit from it who maybe aren't at the moment. So I really appreciate the opportunity. Thank you so much. And again, any feedback that folks have, please send it over and let us know what you think.
All right, that's great. And you made a comment during your session today that learning math is all about seeing connections. And that's what this product is to me, Don. It's about seeing the connections, not only in teaching the math, but as I just a moment ago stated, is about seeing the connections in the various ways that this can be used. So it's fantastic. It's another tool that's in the toolbox here for us as assistive technology professionals. It's no doubt it's going to further assist each of us as we better serve those that we support, as well as the various communities we're part of, teaching, disability supports, technology, all of the various types of communities that we're part of. And I just noticed here, Maureen is asking if we can share your contact information. It had been put into the chat ways back. I'll just add it in again here so that it's there. It's these chats in these webinars scroll so quick, it's very easy to lose track of. So there you go, Maureen. Hopefully that came through for you. So lots of thanks in the chats here about this massively impressed and fantastic, amazing tool. And I know that we've also got Lyle, who was geeking out along with a lot of other people. So again, thank you, Don, very much for this. And your continued support of those in the assistive technology profession and our accessibility community, as has been evidenced by your openness and willingness to look at future development of this. Please know that it's greatly appreciated, and we look forward to you keeping the AT community up to date with the progress that MathWhiteboard makes as it continues to grow. So please do stay in touch and let us know about those updates. Happy to have you back anytime. And yes, so just lastly, for everyone here today, as we end this webinar, I want to thank you for joining us. And remember, you can't spell education without AT. So until next time, take care and stay safe.